RCHUB International Foundation for Research and Education, an ISO certified.
And deploying a model for a research. So this is the third day, how we are going to create and deploying ML model, that is machine learning model for the research areas. In the first day, we have discussed about the basic components of ML and how the foundation of research has to be done. In the second day, yesterday, we are mainly focusing on data pre-processing with an ML packages. So we're using a Python packages we have discussed. And today we are going to make it creating and deploying an ML model for a research. So is it possible for me to cover all the topic of ML model? No, we are going with the structures. So based on your research, you have to create and you have to deploy with the ML model for your research work. It's mainly focusing on novelty. So if 20 participants are here, 20 participants will not have the same model for their research. They have to go with a deep analysis and they can create and deploy their own model in order to make a better efficiency. So before starting today's third date, I will come with a basic technique. There are certain basic things you have to know that. So what is the difference between whether you're going to generate a product or whether you're going to do it for a research? Remember that both the things are entirely different. Of course, for both the things, we are using a machine learning. The business people, the software people, they are normally generating the product. Whereas the researchers, they are also going to use an ML. And these people also going to use an ML. Here they are mainly focusing on customer satisfaction. So they will has to go for customer satisfaction in order to make their product, not with an analysis. If the product is satisfied by the customer, then their business will be grow very fastly, and it is mainly focusing on money minded. It is only a business. Whereas when I come for research, how far I'm going to use these machine languages, and especially here we are not going with a customer satisfaction. We have to create a model. Look at that. We have to go to create and deploy the model. The two words very important: create and deploy. Deploy the model. And here, very important thing, it is of efficiency. How far your algorithm is very efficient compared to the existing algorithm. This efficiency can be of any type. It can be depends upon the time, or it can be depends upon the space, or it can be depends upon the data we are using, or you can go with the performance evaluation. So this is the thing you have to understand, that we are not a software developer and we are not mainly focusing on customer satisfaction, and we are mainly focusing on efficiency of your novelty algorithm. The word which I'm using, novelty, it must be different from others. How far my algorithm is different from others in order to use it for the same problem. For example, I'm going to make it to predict the heart diseases, right? In this heart diseases, I can use X algorithm, Y algorithm, or Z algorithm. Any algorithm you can use it here. And the very comparative statement is efficiency, how far it is efficient, or performance, maybe of accuracy or precision or Z score, like this. So the word deployment, you should understand that it is not just like running a program or compiling a program or testing the program. If you go for software, they used to type the program and they used to test and they used to go for implementation, and that is called as a software product. Whereas when I come for deployment, I have to go for the data requirements. So what data requirements you are going to make it here? And the input must be maybe your data set or any other format you can have it, maybe a data set. I'm saying that if you want, you can use a data set or images or videos or any other inputs. We can able to use it here. With a multimedia content, you can use it here. Media content, you can use it. And output is mainly focusing on evaluation, not with a customer satisfaction. Output is mainly focusing on the evaluation of the output, and it can be either a prediction or classification. You can go here either a prediction or you can use it here either a classification. It depends upon the problem which has been chosen here. So today we are going to make it. So first you have to check the input and what is the output we are going to make it here. And meanwhile, we have to go for train the data or test the data and select the model based on your performance. You have to select the model and we have to go for test the model. And we can come here with performance evaluation of the model, performance evaluation of the model. And at last we came to conclude. So this is what about the research types. Whereas it is not a software, it is a research. So I can't able to come with all the 20% or 30% inside my participants. All the 20 or 30% may have a different problem, but you have to understand the structure. The structure is more or less same. The choosing the algorithm and creating an algorithm on your own, or you're going to make a hybrid algorithm, it is also possible in order to make your research very effectively compared to with the existing researchers. When I speak existing researchers, the researchers belongs to 2025 or maybe 2024, not with 2023, in order to provide you a novelty. Because if you go 3 years back, AA was not familiar, but when you come for now, AA is very familiar. So comparatively 2 years back, it is not familiar, but now we are familiar with day to life. We are using this AI concepts here. So you should have a little awareness about the deployment. Now I go with the presentation, and today also I'll come with a program and I will explain. Since why I'm explaining with the program is our heading, it is a workshop, 3-day workshop. So it must be a program oriented, not with a presentation oriented. So that is what I'm coming here. So first one, we are going for creating and deploying a machine learning model. So these are the 5 phases, which is mainly going for creating and deploying a ML model for the research. So first one is quite common. It is problem definition and data understanding. This is the very difficult task also. Once your problem definition is clear, once your data understanding is clear, then we are going for the next, which has been discussed yesterday, that is of day 2, which is of data pre-processing with the featured engineering we have been discussed. And today we are going to make it with the model development and training. And as I said, model evaluation and refinement. And at last we are coming for a model deployment. So these are the 5 phases for today's environment. And here also I'm having 6 to 7 programs. Let it be, I'll try to explain very slowly. Since yesterday I was with 15 programs, I have to make it finish in time. So I'll make it very fast. Now I'll go here with the first program, and then I will come with an explanation and we can go here. So I'm going to use as well as I'm using a Sublime editor. So whichever editor you want, you can use it here. So I'm opening here. Now I'll go with the first program. Then you can see that this first program is mainly focusing on example 1. I'll come here. Better I'll show the examples. Now look at that. I'm going to create a one folder. Let it be of temp. Okay. Look at very carefully, and temp. Inside the temp, I'm going to copy and paste it because I'll show that how this ML model going to support. Now look at, I'm going to paste it here. Okay. And now I'm opening here. Previously it was in my folder, in day 3 folder. Now I'm using a temp folder and I'm making sample 1 and I'm making here. Right, and you can see here this is the Python code, and look at very carefully. So I'm using a model packages. What are all the models I'm using? One, it is pandas, another one it is of NumPy, and you can see I'm using a sklearn of model selection, which is used to train and test, which is coming under here, which is predefined. And yesterday also we have discussed about pre-processing with a standard scalar, and this is a simple supervised algorithm. I will explain very clearly. This is a simple supervised algorithm. Anyway, I will explain. And you can see next thing is of linear model, and next one I'm going with metrics, and this is job line. And you look at very important. See, there are predefined data set is available. sklearn dot data set, which I'm going to load iris, which is available of internet. Now I copy this sklearn and data set, and I'm going to make it with the search engines. You can come here with any search engines, whatever the search engines you are using here, you can go here, right? And you can see I'm going to paste it. Look at here. So this is a data set of sklearn, which the default scikit-learner, since it is an open source, they are being given. Click it. And you can see here there are various loaders are available. Okay, and you can see here, suppose I want to go with the dataset utilities, you can come here. I'll come here. Now look at here. Yes, this is called as skdataset.loadiris, and these are all the parameters which has been there by default. Okay, you can see there are by default, you can see the dataset which is available, and you can take the code here so that you can see that skylearn data.loadis. Now I go here with skylearn, and you can see there are different types of dataset is also available. Whatever the datasets you see here, you can see load digital, load virus, and now you can see this is what I have taken. Load iris dataset I have taken for classification algorithm, which is by default this ML model support us. So the person who is going with the load iris, they can take with a sample. No, sir, I want to go with the sample images. You can see there is a one data set which is called as a load sample images. And you can see load liner UD. So you can see that written the physical exercise of liner UD data set. So these are all data sets which is available by default with the help of one packages. It is called as a sklearn data set. So even if you want, you can go through here what are all the various the gas consists of so many data sets and so many packages is available with the sklearn. And you can see even sklearn.svm, sk.tree or sk.utilities. So you can understand that this ML model supports us in order to make it. That's what's here. See the utilities to upload a popular data set and artificial data generators. So among that, I have used only a one data set for my problem, which is called as a load iris, which has been here. If you click it, you can get the detail about the load data sets. So it consists of 3 classes and sample per classes is 50. So total sample data is 150 and dimension is 4, and you can see feature is real positive. And you can see that method which consists of, and if you want, you can click the sources also for checking how the data set has been stored here. So these are all the things has been by default. Okay, now I'll go to the code here. So you can see that's what I'm using. So I'm using a data set and import a load iris. And load iris, I'm going to keep it as a iris and I'm going to make it a data. And I'm going to make it a DFO species of iris target and coming here. So you can see if you're very clear in the research and if you go with the packages, any particular packages, most of the work will be very finished very soon. We no need to depend on others so that you can go here. And now you can check it here. So this is a one thing of defining the features of X and target of Y and initial data sample set and the target distribution, right? And you can go here. So we can come here. See phase 2. As we discussed, there are 5 phases of that. First one, it is of problem definition and understanding of data. So that is what I told, that understanding of data I have taken from the data set. So this is the first phase. Whatever the research you are doing, you have to go with the first phase. Second one, you can see phase 2. What is phase 2? It is data pre-processing and feature engineering. Look at the code here, very important. So I'm coming here, it is of data phase 2, data pre-processing. In that, see, so that's what I'm giving here. 2.1, it is of data splitting. So I want to split the data. So you must, sir, you can ask whatever the problem you are having, but you should understand your research problem and you can go here. This is what data splitting 2.1. And next you can see that it is 2.2. It is with the scaling and normalization. Yesterday we have discussed briefly. And I'm taking with the standard scalars and I'm doing this one. And next you can see that phase 3, where today we are going to use. This is called as a model development and training. And what algorithm you are going to use it. Here they are using a logistic regression. If you want anything based on your problem, see, it is fully completely based on your problem, but the structure should be followed. So first one is what data set you are going to take. Second one, it is of phase 2. Third one, it is of phase 3. So here I'm using a different phases. Now in phase 3 we are using a different. See, one, it is of algorithm selection. So it is of logistic regressions using here. And next one we are coming here, it is of model training, how to train it. You can see there's a model dot fit. It will train the data. We no need to go for writing each and every process here, depends upon the problem. So it is going to fit with the model fit here. And it is of phase 3, it is completed. So phase 2, you know that it is data pre-processing, and phase 3, it is of model development. In that first one, it is of algorithmic selection. So I'm using a logistic regression I'm using here. And next one I'm coming here, it is about a fit model. It is, you can see that I'll go very slowly, it is model training. And next one, when I come for phase 4, it is model evaluation. Very, very important. Based on that evaluation only, whether our research will be accepted or rejected. So evaluation must be comparatively, it must be efficiency compared to the existing researchers. That is what it is of evaluation. Phase 4, you can see one method, it is called predict. And the method of predicts proba. And this is the method you have to understand. That's all. Once you understand the method, and you can see that for accuracy, we have to write the problem, right? I have to write the formula and get the data, and I have to make it everything. If you go for normally write it in C languages. Suppose you want to do your research in C, or if you want to do a research in MATLAB, you have to write everything and you have to type all the even a single parameters I have to take. You can see that's the only thing, one method I'm using here. That is called as an accuracy score. For which one? For Y test and Y prediction. So this is what the formulas, no need to write, and it will be generated with the help of machine learning model. So this is very important. That's what we are saying, that the next generation is mainly focusing on machine learning with the for a research side. So this is model evaluation in 4.1 with an accuracy. And I can come here with the second one. You can see that classification report method. There is a one method in Python. It is classification. All the blue color you have seen on my screen, it is called as a method. And especially for confusion matrix, I have to go for true positive or true negative or false positive or false negative. I have to write a formula for accuracy and I have to make it a generation. But here I no need, just I can go for print of confusion matrix of Y test and Y prediction. So this is model phase 4. So phase 3 is model training, and phase 4 it is of model evaluation. And you can see here phase 4 is completed, and at last we come for phase 5. It is called as model deployment. That's what in my PowerPoint presentation I given a 5 points. First one, it is of data understand problem definition and understanding, and second one, it is of data pre-processing. Third one, it is of model training. Fourth one, it is of, you can go for model evaluation, and fifth one is of model deployment. And model deployment also, you can see I'm going to make it os.make at. Now look at this model.article. Here you have to understand that it is going to create a directory. I will show that example, then you can see that. You can see model directory and it will go for model directory. And you can see that os.path join is there, and you can see the model path, and I'll show that output also. Then you can understand that how far this model machine learning model supports here. So this is what the data we have been using. Now look at my folder. I'll go with my folder where it is there. Yeah, you can see the folder which is of temp. So before executing the program, it is only one file. It is called as a example1. So you can see, look at this folder. So I minimize. Now I go with an ideally basic Python ideally, and I'm going to open. And now you look at, I'm going to open a file of example1. Yes, it is of example. Sorry, I should not open. I should open from temp folder. So I'm going to open example1. And you can see the code. It has been here, the same code what I explained here with the different 5 types of phases here. Now I'm going to run it. It takes some time to create a model and it is going to generate. You can see the output has came here, right? So first one is of initial data sample. Second one is of target distribution. And you can see each and every level of classification. So this is model training 4C. Here it is model 2 completed. So that's what I given here. Features scaled successfully. Phase 2 completed. Phase 3 model development and training. And you can see phase 3 completed. Model evaluation and refinement. So you can see model phase 4 has been completed, and model deployment is, and for research we are using here, so that we have completed the process, right? So this is the way you have to generate for your research work. So all the 5 phases. The problem is in phase 2, what technique you are going to use such that the efficiency should be increased. Similarly, phase 3, the selection is in your hand. Which algorithm if I select, or which model if I select, it will be very effective. For that only, the literature review plays a vital role. You have to go through various literature review in order to make a clear distribution such a way that this researchers has used this algorithm and got an efficiency of, for example, 85% of accuracy. So at least I have to increment to 2 or 3 with 87 or 88. So what I have to do, how I have to go with data pre-processing, including from data pre-processing to all the 5 stages. So this is what I've written the algorithm in supervised learning. I've taken some sample and I've done this one. So this is what coming under the supervised learning. And now we go to the folder. Yeah, now you see one more folder has been generated. This is called as ML model artifact. You can open that and you can see what algorithm you use. Logistical regression model I had used here and standard scalars I had used. You can see it will be coming in the format. So that's what, when I start the program, I have just taken only sample one. Now where this code has been written, you can see the code. I'll come with the code where OS has been joined here. Look at here. Model directory. I'm going to create a model directory, which means that ML model artifact and OS. In my OS, underline the keyword, in my OS, make a directories. And in the, what is the name here? It should be of model directory. What is the model directory? The model directory name should be of model artifact and it must be of. And then I'm going to join the part. And in that, what are the two things I have to join? One thing, it is of logistic regression model.plk and standard scalars.plk model is that has been opened here. So you can see that. So this is the way to create and store all the necessary data with the pre-processing. So this is a first program we have discussed here. So based on that, I have given the first one, it is of dummy generation. Second one, it is of data splitting. The same problem, what I given, the same thing has been given here. And third one, it is of in data processing. We are going with the second part, it is of 2.2, it is of scaling and normalization, right? And third one with a model development and training. And fourth one, it is of model evaluation. In that, we are coming here with a classification report and especially position, recall, F-score, and confusion matrix. Where you have written all this code, only one method. That method, it is called as a confusion matrix. That's what I told that. If you go for normally the same program, I have to write it in some other languages. I have to go with each and every formulas and I have to calculate for millions of data. And the efficiency will be of worst case efficiency. If you throw the millions of data, the time taken to compile and the time taken to deploy, it will be more taken time compared to the ML languages using of Python. So that is what we are using. See, I told that this confusion matrix, if you want to write in C languages, but if you write it here, you can see with a one word, I can make it finish here. It is of, you can see here. So accuracy score with one method and classification report with one method and confusion matrix in one method. That's all. My problem is solved. So that's what you should be practiced with an ML packages in order to make your research very effective, and it is also very time consuming. The same code I have to write, it means it takes each and every line 1 second, and if I throw the data, see what is the efficiency means. If I put 10 data, how much time it's taken. Now you can see here the time taken for this deployment. Now look at very carefully. Even I show once again. This is the code. Now I'm going to run it. Now look at the time taken to execute. How much seconds it takes to run the output. That's very important. Or clear? Not a customer satisfaction or how whether it is supports here. Here we are doing a research work. So we need only the how much seconds it's taken to run the code. That's also very important. What happen if I pass 10,000 million data, whether it is going to support in the same second? If yes, then our algorithm is effective. If no, then our algorithm is not effective. So you should understand that creating and deploying plays a vital role when you go for the research side. So this is the thing is very important when you go for here. So this is the steps which has been involved here. That's what same steps what I had been explained here about model deployment, right? That's what we are coming here with the 5 steps, which is mainly focusing on problem definitions and data understanding and data pre-processing and future engineering. And next one you can see here, it is of model development and training, model evaluation and refinement, and model deployment. So this is the 5 phases you have to implement. So this is the thing I have done with a supervised algorithm. Next, the same thing I'm going with image processing with supervised. So with a different pattern, I thought that, so that not with go with the same angle, let me come with the image processing with supervised algorithm. Suppose I'm interested, especially we are using, these are the 5 steps I'm using for the image processing. Sir, is it compulsory I have to use it? No, it's your own way. First thing is image presentation is very important. Future extraction is very important when you go for here. And supervised algorithm, if your label is known, then you can use supervised, or if your label is unknown, you can use unsupervised data also. So that you can go with that. And you can also, I'm using a standard scalars, and I'm using a k nearest put. Okay, and of course I have to change some modifications. So this is what we are going with a sample 2. Now I'll go with the sample 2. Once again, I will copy from the folder so that you can see how far the difference is there. So I'm going to copy it and I'm going to paste it in the temp folder with the sample 2. And I'm going to open with an ideally, right? So I'll open in ideally. First I'll explain the code, then I'll go with that. So that since I'm coming here with sample 2, this is image with supervised algorithm. See, all the thing together, it is your interest how far you're going to see. Wherever I'm using, see, I'm going to use a SK learn selection. Okay, in this image I'm coming here. What is the thing I'm going to use here? I'm using an endpoint and I'm using a sky image draw. Just you copy and paste it. See, only learning thing is very important. So once again I'm going to paste it here, and you can see what all the things is there. Everything will be thrown here. So it is a package. Skykit.image is a package. If you click this packages, you can see what are all the different types of parameters or functions has been used here. In Skyscape, sky image.draw, you see how many methods are used here. In such a way, you have to learn for your research side, not going through with your own ideas or depending on some other thing. And you can see in sky images how many packages are there. Color is a one package, data is a one package. If you click data, you can see in data what all the things are there. So in data, what all the things are there, what all the methods are there, and you can go like this. The sky graph is there. Just that's what I'm saying, that this sky SKI, which is coming under skyscape images, you can take all the details of ML packages. Similarly, I'll come with that next one. You can see here I'm having a sklearn. This is sky image. Now I'm going with sklearn.model selection. Just you can drop it, sir, where you have taken all those things. Just you can learn it by your own by copying this code. Now I'm going to paste it. You can check it here, right? And I'm going to paste it. Now look at here. See, sklearn model selection. And what version we are using? 1.7.0 version of the documentation. Now I'm going to make it here. And you can see I told no train slash test that split is a one method is that. Now I'm going to click this one. You can see what is the method it consists of. It consists of an array, and what is the test size you want, what is the train size you want, what is your random state want, whether you want a shuffle or not, whether you want to stratify or not. Everything has been given. We no need to write anything, just you have to pass the parameter. Which method you want, how many parameters you have to pass. That's the one thing that the researchers should understand in ML. Of course, the researchers no need to be a programmer, but the researchers can learn the program by themselves and they can do their work. So you can see here how many methods, how many packages are available. You can see in SK model selection packages, you can see there are various things are there. Not only SK. Suppose I come here. Now look at here. In sklearn, what all the things are there? Base, calibration, cluster, and compose, covariation, cross decomposition, data set. So previously I had used this data set. So now I'm going to use it this model selection. Right? In the first program, I use the data set. In the second program, I'm using the model selection. Since it is an images, I'm coming here. In such a way that you can go. That's what our heading it is of creating and deploying an ML model. That's what we are coming here. It is not a model, it is ML model, machine learning model with the help of Learn packages here. Now I'm going to take this sample 2, better I'll explain the code, then we can go here. Same thing. First phase, it is of data generation, where I've taken from the data set, right? And you can see here, all the things are there. The second one, you can see here. Phase 2, we can go here with the splitting, and you can see the phase 2, it is of feature extraction. When I come for image processing, I told that the first one, it is of image representation. The second one, it is of feature extraction. Third one, it is of supervised learning. Fourth one, it is of standard scalars. And fifth one is of KNN algorithm. The same thing I have written here. The second one, it is of feature extractions. And even if you have a doubt, you can see here. Whatever the blue color you can see, you can copy and paste it and you can learn by yourself. Third one, it is of data splitting and scaling. And phase 4, it is of model development and training. And fifth one, we are coming here, it is about model evaluation as the strategy which has been followed for creating and deploying. And this is what the thing we are being here. And now I would like to run the code so that you can see. I'm going to open the file and I'm going to make it example. Look at that example 1 with model article. Now I'm going to open. Since I have not written any code with the OS later, let me see what is going to happen. Now look at here. I'm going to run the model 2, and it takes some times to see the time taken to display all the images. So this, since it is an image related with the supervised learning, and I'm using a KNN. For a sample program, I have taken the concept of like this. So if you want, you can go with some other thing also. So this is the way you have to understand that 5 phases you should understand, and which algorithm you want and how you are going to implement this packages. The important concept is, just like your kitchen room, all the data is available in your kitchen, and you're going to prepare a coffee, you must take a coffee powder. And if you're going to prepare some other thing, you have to, based on, for example, if you're going to take, you're going to cook upma, then you have to take a rava. For chapati, we have to take wheat. This is the concept. Which one you're going to do a research? Appropriate method you have to pick and you have to implement in your code. As a trainer, we are giving all the things, what all the available things is available. So you must train, you must be trained to use these packages. Which packages, if I use it, make my work very reduced and it will be comfortable to provide my efficiency. So this is a sample 2 with a supervised algorithm, so that you can see here, this is an algorithm we have been used here. And next we go here with the third one. I'll come here with this is the one. And next I'm coming here with the NLP. So natural language processing using a supervised algorithm. So I've taken 3. And look at the prediction, look at the strategy here I'm using here. It's my own strategy. If you want, you can change your strategies also. Of course, the order may not change. The data preparation, text processing. So text processing, you can prepare any other methods which you are interested. And next one, it is about feature extraction. And next one, it's model training, model evaluation, and prediction as an NLP. So I'm going with the 3 different routes. One, it is basic, and another one, it is with images, and another one with the natural language processing. With a Navies-based algorithm. So when I have to use a Navies-based algorithm, when I want a conditional probability. So certain algorithm has a certain values. You must understand the algorithm. You should not take and put wherever you want that algorithm. If my problem is with the conditional probability, in order to make a sentimental analysis, or basically it is a conditional probability. Based on this condition, based on this one, how many of, now I can ask the question. Here, how many participants are there? You can see that. You can see here how many participants, maybe of 12 participants are here. So based on this 12 participants, how many of them are male and how many of them are female? In how many of them are active listener and how many of them are slow listeners? I want to predict. So overall, I want the conditions and I want to the output of the predictions. So this is all the things you have can be generated with an algorithm. Of course, after completing this, when I leave this application, if the application is provide me this much male participants and this much female participants, and out of that, this much percentage of male participants are activated, active listening, and this much of female percentage are activation listening, and this much percentage is not activated listening. Suppose consider that the male participants is 90% is active listening and 10% is not active listening, then I can say that, okay, I can consider that. Suppose the more number of slow listeners, then I want to change my way of attitude in order to make my training the workshop. So this is what suggestions has to be given by the application. So then we can say that it is a kind of a research where it is providing a research detail and saying that you must want to change your attitude of teaching or training the participants. So this is what the thing is there. So third thing, we are coming here with a Navies-based algorithm with an example of 3. So I'll go with that. Now I'll come with an example 3. Once again, I'll go with copy the code. And now you can see here, I want to show that also. Now, once I run the image, you can see there is a one more RTCAP files has been generated with an empty in order to make the images, right? So this is all the things possible according to my code I have written. Now, once again, I'll go with the third program and I'll copy it and I'm going to paste it in temp in order to understand how the folders has been generated. Now, I will open example 3 and look at here. So, opening a file with an example 3 and this is with NLP concepts. See, one word model selection already we have discussed. The next thing I'm going for feature extractions, right? In feature extractions, I want to go for text. Okay, now you see I'm going to copy and I'm going to paste it here. I want to make it right. Yeah, I'm going to make it paste it here and you can see here. Yeah, I'll go here. Now you can see here. So when I say it is about SkyTrit feature dot extractions of text, okay, we can go here with feature of extractions, right? And now you can see it is 7.2 feature of extraction. So then you can see how many for data transformation, especially for data transformation, there are various things are there. In that, I'm using that 7.2. It is a feature extraction. In feature extractions, you can look at that, what all the codes has been given here. Everything is predefined. Everything is predefined. And look at the next thing is very surprising. Even Navies Bayes algorithm is predefined with the multinomial Navies Bayes algorithm. Very simple word they have written. If the same thing I want to write it in Java, I have to write the entire process of an algorithm in a classes with method, the same thing with any structured programming. Since I'm using an ML, you see I've just given the word of multinomial Navies Bayes algorithm. And that's where I've taken from sklearn of Navies Bayes algorithm. Sir, is it possible to have all the algorithm? Of course, 100%. And you can see I'm importing OS also. So once I import, automatically one folder will be generated here. So this is with a natural language processing and I'm using a Navies Bayes with one word from sklearn of Navies Bayes. I'm going to take it. Look at here. I'm coming here with Navies Bayes and I'm going to copy and I'm going to paste it. And now you look at here, Navies Bayes 1.9. Then what are all the problem? You look at in Navies Bayes, what are all the algorithms are there? So it is 1.9. You can see the Navies Bayes algorithm is there. First one, Gaussian Navies Bayes. So if you want, you can use a Gaussian Navies Bayes. Second one, multinomial Navies Bayes. If you want, you can see this side. In my right hand side, you can see here Gaussian Navies Bayes, multinomial Navies Bayes, complement Navies Bayes, Bernoulli's Navies Bayes, categorical Navies Bayes, outcore Navies Bayes. So just you can add, I want to implement multinomial. So I have to implement it. Suppose if you want, you can Gaussian, you can use a Gaussian or whatever the algorithm you want. You no need to write all the formulas which has been given here. So if the same thing I want to write, say you can see my screen, the same code I want to make it here, then you can see here, I want to convert the code into Java and I have to make it here. But or I want to convert it to C languages and I can make it here. But when you come for machine learning, it provides the with a one word, I can do the entire process. So the person who is interested in research and if you want to write a code, then you can no need to upwrite. You can just go with an exploration and you can do whatever you want here. So this is what the thing is that. Similarly, you can go for matrix. Now, you can see here what all the different types of algorithm is there. You can see here in supervised linear model, linear quadratic, kernel, support vector and stochastics, nearest neighborhood, Gaussian, and you can see 17 supervised algorithm is there. And in unsupervised, I'll come here with unsupervised also. You can see here in unsupervised, you can go here with around 9 algorithms are there. In model selection and evaluation, you can see it is around the data of 14. It is around 5 it is there. Where this Python is provided ML packages for in order to support the researchers and in order to maintain their work, right? So this is what they are being provided here. So now you can see the same thing. I'm coming here with the data preparation. So this is the data, review data. The person who is giving a review, normally we can type whatever you want about the product, whether it is good or bad or something. And I'm going to make a sentimental analysis, whether it is positive or negative or positive like that. So original data sets, and you can see I'm going to run this code with an NLP. So this is the code which has been here. So I will open the file. So once again, I'm going to open the file. In which folder? In temp folder, I've opened the file. Already I'm having another folder. Anyway, I come with the temp folder, and this is the code which has been here. Now I'm going to run the code so that you can see here the output will be predicted, right? You can see the output. So that I love it. So that the review and predicted, positive and negative. See what waste of money and utterly disappointing, which shows that it is negative. The acting way was okay, but the story was weak, which means that positive. I love it, which means that it is positive. So you can see that this is the output of the sentimental analysis, and you can see the folder. Now I'll go to the folder. Look at the folder. There is one more folder is coming here. This is called as an NLP sentimental model. And you must always look at that, how fast the data has been displayed. I want the running time of the code. If the running time of the code is delayed, then you can say that our algorithm is not efficient. So when we speak about the algorithm, the two efficiency of algorithm, one it is of time and another one is of space efficiency. How fast the running time. So you should understand that. What do you mean by compiling time? What do you mean by running time? And what do you mean by executing time? The compilation time is taken the time code to compile it, right? And running time, you can see that if I give the input, that's very important. If I give the inputs, 10 inputs, what will be the output? If I give 1 million input, what will be the output? Whether the time of running is different or same. So compilation time plus running time, we can say that it is an execution time. So you should be always aware of the execution time also. So this is what about the three concepts I have taken for the sentimental analysis, right? And next I'll go here with supervised algorithm. Of course, I'm not going with all those things. First, we will go with unsupervised algorithm. So previously we had discussed with supervised, and I'll go with an unsupervised. Similarly, I have the code for an image segmentation with unsupervised, and natural language processing with an unsupervised. And I'll try to go with the eighth one. It is of reinforcement of algorithm. So whenever I say reinforcement, you should be consider the two things: awards or rewards or punishment or anything. So you should be always, when I say reinforcement, the number of participants is more in my workshop, then I will get a reward. If the number of participants is less, then I have to need that. I have to change my process of explaining the workshop or training the participants. So this is the thing I have to consider. Now I'll go with the example 4 and example 7. Meanwhile, we can say that I'll go with an example 4. Right. So once again, I'll go and copy it here from example 4, and I'm going to come to the temp folder and I'm going to paste it, right? And I'll open here. So file, open, you can see I'm going to open with example 4 now. Same thing. So many times I told that sklearn.dataset, sklearn.preprocessing, and now I'm using a clustering algorithm. What algorithm I'm going to use? K-mean algorithm is going to use. Suppose you're going to use a cluster, you can go with any other algorithm also. Now I'm going to use it with a K-mean algorithm and scikit metrics and matplotlib, which I have to on, and one more thing, Seaborn. So if you want to install a Seaborn, you have to go for pip install of Seaborn. See, because this is a new thing, one packages which is of Seaborn packages, you can see here, which is used for displaying the content. You can see here Seaborn in Python. So this is a statistical visualization of data. So if you want to go with a statistical visualization, you can go with Seaborn. See, seaborn.python.org. So it will provide all the detail. We no need to worry. And if you want to learn, you can learn with an object. So you can see different types of objects as being available. So when you go with the research, if you know with a little coding skills with how to take the data, so it's very easy to complete your researches very fastly. So now I'll go here with example 4 in order to execute. Anyway, I'll come with the code. So as usual, first one it is of data collection. Once again, I'm going to load the same thing with the load IDs. And the second one is of data pre-processing, and I'm going with the concept of scaling. And third one, you can see here it is of unsupervised model. So it is not easy to explain within 1 hour unless you don't have a practice of writing a coding and exploring the packages of Python. So you should go more time in spending a time with the Python packages, and you have to take it here. So this is step 3 with the packages. And we can go here with the model phase 4 here with the, see here, you can see here it is a phase 4 with evaluation and interpretation. And in that first one is of clustering distribution. And 4.2 it is of comparison with the true labels, right? And you can see here, now I'll come here with the 5th one, it is of deployment. And at last, I'm going to upload a folder. See, now we are going to generate a folder name. It is called as a unsupervised model article. Now look at that. We go to the folder. So here we don't have a folder of unsupervised. Anyway, I'm going to run it. So since it is, sorry, I want to run the example 4 file. So I'm going to open example 4 where there is no folder of unsupervised article. Now I'm opening the folder 4 and now I would like to run the code. Now look at the code here. It takes some more time to display the screenshots because everything it is of image oriented. That's what. So you can see that it is of a different number of clusters. So I'm going to close it. And now it is k-means cluster and I'm going to close it. And you can see 3 types of clusters with a load iris data 0, 1 and 2. And you can see it is of 2 spices label, so that you can see that. Even if you want more graph, you can generate with the key use of k-mean clustering, right? So this is the thing you have to understand. So now I will go, anyway, if we have a time, I will go with 5 and 6. Anyway, I will come with the 7th one, which is of rewards and punishments, which has been with the reinforcement algorithm for supervised, unsupervised algorithm, right? So this is example number 7. I'll try to complete with that, right? Anyway, I'll come. Now look at that folder. Yeah, I'll go with the temp folder. I have to show that. Now you can see there is a one folder which has been generated. It's called as an unsupervised model artifact. In that, I got 2 files. One it is of k-mean model, and the one is of scalar for unsupervised. Now I will go for the 7th exercise, since it is of a reinforcement algorithm. I'll go here with day 3 and I can come here with 7. I think I have to go here with 7 or 8. It is 7, right? Anyway, I'll go here with 7. And this is, see, one algorithm agent. Now you should understand the recent trend. We are following agent learner. All the AI, whatever the AI used to chat is coming under the agent. The agent itself will learn and it will predict and it will give the suggestion. That's what the AI is doing. Most of the AIs we are coming here with an agent learner. So I have defined the agent learner, and this is the package I have been created. This is a constructor where I'm using, and I'm using its action. So what action I'm going to take it? Either award, you can see that I'm going to make it either a reward is an action I'm going to make it here. And we can see the output of this one. Reward, you can see, yes, yeah. Either an award or reward, we are going to make it here with an action, with a code. And this is all agent code, which has been originally written by us. Where here we don't have a predefined package. Currently, we don't have any predefined packages for agent. Maybe soon the agent packages will also come so that we can comfortably sit and pass the agent parameters. I hope so. Right. So this is what the thing you can see here. So Q learning agents is there. Currently, we don't have any agents, even if you go for that. And better we can see within 1 month or 2 months, maybe the Skylearn kit or skit, maybe they will be provided with an agent learner where it is going with an action and reactions is going on. If they get a best word, then we are saying that it's reward. Now I would like to go here with file number 7, right? So that it is of file open, and I'm going to make it here with example 7. So I have to copy from day 3. So I'm going to make it 7, which is of Q enforcement algorithm. So I use the agent here. It is called as a Q learning agent. What do you mean by agent? The agent will perform their actions and reactions based on the data by itself. We no need to train or we no need to test. There is no need of training and testing data for the agent. The agent will perform all the tasks. That's what the state, actions, reactions, everything has been given here. Now I would like to run the code so that you can see here. See. So what reward? If the episode 100, it got a reward of 9.30. Episode 200 got 9.20. So each and everything, at last we can see that whether it is recommended or not recommended. Once if you watch web series or when you watch movies, at last they will ask the recommendation, whether you like it or whether you double like it or whether you are not interested. So that based on your suggestions and the values of rating can be done here with the help of this reinforcement algorithm. Based on the input provided by the user, we can able to predict it. So this is what about the reinforcement algorithm. Anyway, I'll go with one more thing with an image segmentation using unsupervised algorithm with an example 5, right? So that with that I can stop it. So I don't waste the time. Now I'll go here with example 5. So I'm going to open example 5 with an image oriented for the, anyway, I'll copy and paste it, then we can open it, right? So I copy it and I'm going to paste it in temp folder, and now I'm going to open this one, right? So this is with unsupervised. Previously we have done here with supervised, and now we are coming here with an unsupervised. And here also I'm using a sklearn sklearn.cluster, and here I'm using a sk images, and I'm reading the image path, and you can see the same thing. What are all the methods? So preparation for cluster is phase 2, and in 3 applying a claim in clustering for segmentation. Right. So whenever you write the algorithm, you please write with the phases so that it will be easy for you to understand that. And fourth one, you can see reconstruction of segmented images. And fifth one is of displaying the results. So this is the 5 things which has been used for unsupervised algorithm in example 5. So now I will open and I will run the code for 5. Okay. Yes, now I'm going to open the file example 5. Okay, so I have been open, and now I would like to run the code. So now you can see that it is with your image path. Whatever the path you want, you can make it here. So you can see that by default image it has been taken, and you can see that output. So this is the original images, and with a segmentation of 1, 2, 3, 4, and 5. Of course, here also the segmentation is 4 with the 5 colors we have been making here. So this is the code which has been used for unsupervised algorithm. Since it is not a labeled data, we are coming here with an image processing. And similarly, I had left only 2 things. One thing with the natural language processing is there, and another one it's of semi-supervised is also there. So like this, you can take the code, whichever algorithm you want, you can make it here. So that I think I can come to the end of the session, right? So with that, I can stop my session, and I hope so I had covered most of the creating and deploying of ML model. And as I said that even you can go about semi-supervised. I have the code, but I don't have a time to explain the code. So that with that, I can stop this session. And if you have any queries, you can ask the queries, please. The participants, if you have a queries, or please, I request you to give the feedback about all the 3 days of this session. It's a request, and you can fill the feedback, and you can subscribe the YouTube channels. Whatever I've taken, it will be available there, YouTube channels. And I request all the participants, in order to get your certificates, you can fill the feedback. It's compulsory, you need to fill the feedbacks. So we request your feedback, valid feedback, and if you want to change anything, we are ready to change it, the way of presentation or the way of the content or whatever the descriptions you needed, we are ready to do that one. And if you're interested, you can go through a YouTube subscribes, and there are various workshops out there. Even I have been taken with the XAI, with AI, how to use an AI in research. All those channels are available in this YouTube channel, so that you can subscribe. So I request the participants to give the feedback. Any queries is there, you can send the queries, please. Is there any queries, please, participants? Otherwise, I request the participants to go for giving a feedback, so that based on that, I can, what the next generation we have to change it. I think it's times to end. I think no feedback any participants are ready to give the feedback? If yes, we can wait. Okay. Thank you for all the participants for this 3-day workshop. Thank you very much.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.